Dear students, we will now continue vectors. We have already finished seeing vector addition and then practicing a little bit of sums. Now we will continue vectors. Now in this session, I'm planning to cover resolving a vector into its components, then unit vector concept, then dot product, then cross product. So then this is what I want to go about. Okay. Now let us now start with resolution into its components. Now already we have seen by in our addition topic that a vector A plus B gives you C vector like this. Okay, triangular method of addition. Now we can also now, this means now A plus B will give you C means, then we can also say that A and B are component vectors for C. Why? Because now C is obtained by means of A plus B. That means A and B are components of C. Now it is very useful if we can have these components perpendicular to each other. That means now instead of having this kind of angle between them, what is the angle between them? Theta, because we have this c squared equal to a square plus b square plus 2ab cos theta formula to be applied for this particular triangular diagram of vectors. Instead of that, if we can avoid using that particular theta and then make it as perpendicular to each other. Suppose for example, now this is A vector, this is B vector, therefore this is now C vector, then becomes now simple Pythagoras theorem we can apply. That is, we can eliminate the third term, the plus 2ab cos theta, because theta becomes 90 degrees. Therefore now that's why it is useful to have these components perpendicular to mutually perpendicular to each other. Now in which case then this is called as resolving C into two mutually perpendicular components. This is one part of it. Now the second part of it is even more useful if we can have these two perpendicular components to be along the x coordinate direction, x axis and the y axis. Because usually you will have in your geometry, in your situation, you would always have the x axis and the y axis and the origin. Therefore now we will say that if we can make this one of these, let's say for example now A vector component to be parallel to x axis, and then B vector naturally will now become parallel to y axis, then it will be even more useful. Therefore now such kind of a resolving is called as along x and y component. Now the x axis y axis can be chosen very conveniently by you depending upon situation. Like for example, suppose now in your later chapter, like the Newton's laws of motion chapter, you may come across inclined plane of angle theta on which a block is resting mass m. Then mg is the weight or the gravitational force on mass. Now you may have to resolve it into its components in order to analyze and write down the equations, force equations. Now the convenient this thing is, because now it's going to slide down along the inclined plane like this. Therefore, one axis you can consider as this now x axis, and then you can consider this as y axis. Therefore, you may have to resolve this particular one force mg into one along this direction x axis, one along the perpendicular y axis. It will come down like this now. Therefore, now such kind of cases, then you would have actually now defined this as x and this as this as y. Okay, therefore 90 degrees. Therefore, then you will be resolving. Now let us now take in this particular inclined plane block only. Now, what is the resolved this thing? It is like this. Now mg vector is now to be taken as addition of one vector like this plus one vector like this, and the angle between them is 90 degrees. Okay. Therefore, now what is this? And therefore, then what is this vector? How much? This vector how much? Whereas this vector is mg. Mg is the magnitude. Therefore, then what is it? Then we have to find what is the angle between this and this. Okay, now angle between this and this. What is the angle? Now is it theta or 90 minus theta or something else? Now this is where now one more tip or trick I can advise you like this. Now what is this in this particular figure of the inclined plane? What is the angle the theta is between the inclined surface and the horizontal? Now what we want this particular component to be along inclined surface, whereas this is now vertical. Therefore, what is the angle between inclined surface and the horizontal is theta. Now, in which case, then the inclined surface and the vertical is going to be 90 minus theta. So understand this. Now this is now very key because most of the students find it difficult to actually calculate the angles fast. Okay, ultimately they'll be definitely be able to calculate it correctly, but then it takes a long time for them. Now this is where I want to give you a tip like this. Now, if an angle between two lines, let us say now this is one line and this is another line, and an angle between them is theta, then then the angle between the two perpendiculars to each of these lines, let us say now this line is perpendicular to this line, and then this line is perpendicular to this line. Then what is the angle between these two dotted lines, which are perpendicular to the given two lines? Okay, now this angle is how much? How much means it also will be theta. Okay, just go by this particular understanding that if the angle between any two lines is theta, then the angle between the two perpendiculars to these lines also will be theta, because now one line is perpendicular to the given line A, another line perpendicular to given line B, that is line C perpendicular to line A, line D perpendicular to line B. If the angle between A and B is theta, the same angle will hold good for the two perpendicular lines. Then the Carol, now you may have certain doubt about this, whether if this angle is theta, then angle between any two lines will be, there are actually now two kinds of angles. One is this angle is theta, this angle will be one angle, this angle is one more angle. Then which one we should now take it as theta? Obviously from the figure you can make out that the theta is acute here. If it is acute here, then this angle acute only will be theta, because this fellow is obtuse. Therefore, obviously common sense says that which angle is now theta, which angle is 180 minus theta is very easy to make out from the acute obtuse angle, especially when you draw the diagram somewhat accurately. Therefore, now that is not the issue. Whereas if you are getting confused about which is theta, then follow this particular advice about which looks acute and obtuse. Therefore, now you will not make a mistake like this. Whereas, okay, now come back to this. Suppose now in this case what happens is, in this case what I am saying is, now angle between the horizontal and the incline is theta. Now we want to know the angle between the incline and the vertical. Therefore, now incline is a common direction for both this and this are the same. Whereas now this angle is now theta with the horizontal. This angle naturally will be vertical, will be the 90 minus theta. So understand this kind of a thing, that in the case of two perpendicular to the two lines is going to be the same angle theta. Then one of them perpendicular, one of them remaining the same horizontal. Then it will be the 90 minus theta. Understand this kind of a simple tricks which will help you to quickly do the angle fixation fast. Okay. Now let's go further on this. And therefore, now I am saying that now resolving into components means, suppose you have a vector like this. Now I want to resolve along which directions. Now obviously, as I said, now it will be convenient for most of the situations, it will be convenient to have them as mutually perpendicular components. Then the second question is which is the x-axis, which is the y-axis. At least one of them will be dictated by the situation. Okay, demands of situation. Like for example, in our case of the inclined plane this thing, obviously from the situation of solving the problem, it will be more convenient to have one as the x-axis as along the incline. Therefore, then automatically y-axis becomes fixed. Therefore, one of the axes to be chosen will be conveniently chosen, and the other one will be automatically fixed. Okay. Therefore, now that is then what happened. Therefore, then what happened? Suppose now you have this is your C, and then you want to define this as x-axis and this as y-axis. Then this is the x-axis parallel. This angle you should be able to make out. Once you make out this angle, then extend this particular line up to this perpendicular. Therefore, now this is one vector. C is equal to A vector plus B vector, and the angle between them perpendicular. Therefore, then A, the magnitude is equal to C times. Now we come to one of them will be cos theta component, other one will be sin theta component. It will be easy for you to make out which is cos theta, which is sin theta, because from the definition of the trigonometric ratios. Obviously, like this now there also some students find it actually a little bit difficult. Not all, but then some students find it difficult to make out which is the cos theta component, which is sin theta component. Now it is pretty obvious from the definition of cos theta, adjacent side by hypotenuse. Now this vector will always be the hypotenuse. Which one? That is the vector which you are now trying to resolve into two components. That is now the C, for example, in this case will be the hypotenuse. Therefore, you are now trying to find out one side is like this, other side is like this. Therefore, this side which is now adjacent to the theta angle, okay, adjacent to theta angle will be the cos theta component. Therefore, now the opposite to the theta will be the sine theta, because definition of sine theta is opposite side. The opposite side to the theta will be the sine theta component. You can easily write it down. Suppose now instead of now this angle, suppose now you are given this angle as, let us say, alpha. Then obviously what happens, adjacent to the alpha is your c cos alpha. Okay. Therefore now this is c cos alpha magnitude. Therefore this will be opposite to alpha, will be c sin alpha. Therefore depending upon that should be pretty simple for you people to make out. Therefore now what I am saying is, therefore now the vector c is now resolved into two components which are mutually perpendicular. Most of the cases you would prefer it to be perpendicular. Then in fact there is one more thing which I can say is, now theoretically a vector can be resolved into any number of components. For example, now this particular c can be taken as equal to, c is equal to a plus b plus d plus e vector, and then this vector f. Therefore then what happened, what I am saying is, now c is equal to a plus b plus d plus e plus f, because you get from very start to the very end, this is a c vector addition. Therefore now in fact in this kind of a case you can always say that c can be taken as components of c can be 5. Therefore now so theoretically speaking there can be any number of components, whereas what I said was, now number one, it is therefore a vector can be theoretically resolvable into any number of components, but then ideally in all situations we would prefer to have only two components, and then that too also is two perpendicular components, and then one of the directions you will be that will be taken convenient axis direction, other one will be automatically fixed as the perpendicular direction. Okay. Therefore now this is the sum and substance of the resolving into components topic. Next we are going to see unit vector. What a unit vector is, like this, very simple. Suppose you have a vector here, this is a, and its magnitude is naturally is a. You can write it as like this, or you can write it simply as a, like this. We know. Now which is the vector, what is the vector which has got the same direction as the a vector, but has got a magnitude of 1, that is unity, is nothing but now the same direction, but then this value is 1. Okay. Now this is called the unit vector along the direction of a. Therefore it is now simply written as, this vector is written as a cap. Okay. Instead of the arrowhead on top, you put a hat or a cap. It's also called as a hat. Now a hat means now the magnitude of this particular a hat is always equal to unity, and the direction is directed parallel to a. Okay, same as the a vector. Now therefore then you can always say that a cap is nothing but a vector divided by this by magnitude. Why? Because when you are dividing this by magnitude, what happens naturally, then the resulting value is only 1. Therefore now this is what is the definition of unit vector. Now why is it necessary to have the unit vector is like this? Because as I said now just before this, we just saw that a vector a can be resolved into two mutually perpendicular components, one along, let us say, a chosen x-axis, other along the automatically fixed y-axis. Okay, therefore this is equivalent to a cos theta, where now theta is this angle, and then this is equal to a sin theta. Now this is the magnitude. What about the direction? As we know, this should be termed as along x direction, it's termed as along y direction. Now there is then what we do is, we have a convenient system of saying that, let's call it as now x cap, let's call it y cap. What does it mean? X cap means it has got a magnitude of 1, and then its direction is along the x direction. Now therefore now you could actually call this particular vector as a cos theta magnitude and then x unit vector. Okay, this therefore now becomes, when you are multiplying by means of a cos theta is a scalar, is a value, multiplying by means of a vector which is a unit vector. Therefore now the value of this particular vector as a whole is only a cos theta, and the direction is determined by means of this x cap or x hat, which is along x direction. Therefore now similarly now you could actually now call this particular vector, perpendicular vector, as a sin theta y cap. Now what mathematicians have actually now decided is, instead of having it as x hat or y hat, they are calling it as I cap and j cap. Now it's more convenient because now the x and y symbols can be reserved for coordinates. Therefore you don't have to confuse with this vector, unit vector x as well as the coordinate of any particular point as x comma y. Therefore, you can keep them apart. Therefore, they decided to name the unit vectors along x direction as I cap, and then along y direction as j cap, and then supposing you have the z coordinate also, z coordinate, then it is determined as k cap. Therefore, I cap, j cap, k cap denotes unit vectors along x, y, and then z directions respectively. Therefore, now you can say that a vector is equivalent to a cos theta I cap is one component along the x-axis plus a sin theta into j cap along the y-axis. Therefore, now this plus that. So this is called resolving into two components, mutually perpendicular two components. Okay. Now, this is what it is. Now you can also have a space. Suppose a space vector into 3 dimensions. You can also have it as a equal to some a1 I cap plus a2 j cap plus a3 k cap. Okay. So then such a kind of a thing is always possible. Now the next thing what we're going to do, as I said, now you should remember this. Now this definition of a unit vector is a cap equal to a vector divided by the modulus of a vector. It can also be written as I said, instead of writing this big modulus kind of symbol, you can simply write as without the vector symbol on top, it is called only magnitude. Therefore, this also is important for you to remember continuously. Okay, so now we have got this. Next thing what we need to do it, we have to go for what is known as dot product. What is meant by dot product? I'll tell you. Now so far we have seen addition subtraction of two vectors. What about the multiplication of two vectors? Now we already have actually seen and then used multiplication of a vector by a scalar. Supposing now let us say now a is a vector, and the 4 times a is called a scalar multiplication because 4 is a scalar, or it could be generally something like mg. Now g is acceleration vector, whereas m is a mass, it's a scalar. Mg is a weight which we know is got by means of multiplying acceleration vector by means of mass. If such kind of a scalar multiplication, already we know it doesn't change. Like for example, you also know this. Now Newton's law says force vector is equal to mass times acceleration vector. Now there one more thing also is, now you must remember it. Now the direction of the left hand side is determined by direction of the right hand side. Therefore, if the right hand side acceleration is like this, left hand side is force like this, then force and acceleration being the vector, they have the same direction because multiplied by a scalar. Now similarly, now dividing also is like that. Like for example, now if we say now force divided by mass equal to acceleration, it means now dividing by a scalar doesn't change the direction of the vector is congruent, in the sense both sides should be same. Right. Now this is all that you know already. Now we'll go to dot product of two vectors. That is, when you have two vectors, then you can multiply them. Now there are two ways of multiplication which are involved in this. One is called the dot product or the scalar product. Dot product also is called as a scalar product, and the other one is called the cross. Is called the cross product. Is also called as a vector product. Now let me now say like this. Suppose now this is a vector dot b vector. When I put like this means dot product. Now what is this thing is, number one, it is a scalar. That is, a dot b will give you only a scalar. It will not give you a vector. Then the second is, now if you put a scalar, then it got only value. Therefore, then what is the value is ab cos theta. What is the theta? Is the angle between a vector and b vector. Let us take for example, now this is a vector, and then this is b vector. Therefore, now what we want is, okay, we'll just now move this particular b vector and then to the foot like this, and then therefore now redraw this as b vector. Okay, foot to foot. Now understand this. Therefore, foot or what you call a tail to tail. Okay, understand it. Then what is the angle between them? As you know, is now in this case there is now the angle between them. What is now a cos theta? We can drop a perpendicular from here. Now this much is a cos theta. Already you know this. Okay, this side is a cos theta, and of course opposite side is going to be a sin theta. That we don't require now. Okay, don't worry about it. Therefore, a cos theta into b. Therefore, this length into this whole length is called a cos theta into b, can be written as ab cos theta. Therefore, now this particular product of this a cos theta length into b, or you could also have it like this. Okay, therefore now this is what defined as a dot product, which again I am telling you now, when you are multiplying two vectors by means of dot product, it becomes a scalar as a result. Okay, that does not have any direction. You got only a value, which is what I said about ab cos theta. Now This is it. Now you could also have the same thing in a different manner. Like what I'm saying is, now you could actually now have, instead of AB cos theta can be different. Now in this case, what I did is A cos theta into B is a multiplication. A cos theta into B. Now you can also have it as B cos theta into A. Into A also is the same. Now how is it? Now this is B. This is now theta. Therefore, where is now B cos theta here? When you just extend it a little bit, like this, and then drop a perpendicular from the end of B, this perpendicular. Therefore, then what is this length up to this particular point is B cos theta. Therefore, B cos theta is the whole length, the extended length, multiplied by the smaller length, which is A. That also will give you the same value, because AB cos theta is nothing but BA cos theta. Therefore, now both can be thought of as this. Now I want you to now remember one more terminology here. Okay, let me just now redraw this. This is A, this is B attached at the tail, and the angle is theta, and therefore now drop a perpendicular from A, then this much is called A cos theta length, and the whole thing is B. If a product of these two is called the dot product. Okay, now what is the A cos theta is also called as projection of A vector along B vector. When I say B vector along B vector, it means B direction. What is this much length is projection. That means suppose now a shadow of this A vector is captured on this horizontal, so-called line along the B direction. How do you get it? When you're dropping a perpendicular from the head of A onto the B direction, drop perpendicular, then this much is called as projection of A along B. Now, when we do this reverse, that is, when we do it as I said about the B cos theta, then what is this much is, drop a perpendicular from the B, then this much is called B cos theta, is nothing but the projection of B vector along A direction. Okay, along A. Therefore, now this kind of terminology is also you must understand now, right now, because we will be using such kind of terminology later on throughout your physics course, right? Therefore, now we got this thing as a dot product. Now where is it used? Where is dot product is used is in later you will come to know about it. There is a terminology in physics which is called as work done. Work done by a force F on a particle when the particle has displacement S. S is a vector, displacement vector, force is a vector. Therefore, work is a scalar. It has got only value, no direction. E is defined as always force dot displacement. Okay, this is one part of it you must know. If such kind of cases about dot product usages, we will see about it later. Next, then this thing is, suppose now, how do you now do the calculation of dot product? As I said, it is going to be F S cos theta. Now another way of actually calculating it is, if you have it resolved into component, like now F can be resolved as Fx is the value along x direction with I cap plus Fy j cap plus Fz k cap is as you have learned just now, that can be resolved along the three directions into its three components, which are Fx component multiplied by the unit vector along x direction I cap, j cap, k cap, dot. Then similarly, now displacement also can be resolved into I cap plus k cap. Therefore, then when you do the dot product, what you must do is it like this, that term by term. Now you must know this particular table. I cap by I cap equal to 1, because 1 into cos of angle between I cap and I cap is now 0. The cos 0 is 1. Therefore, cos 0, this is equal to 1. And then j cap and j cap also is equal to 1. K cap and k cap dot k cap also is equal to 1. Whereas I cap dot j cap will be equal to 0. Why? Because nothing but as per our definition of dot product, which is mod I is 1 into mod j is 1 into cos of angle between I cap and j cap. That x and y direction is what? 90 degrees. Therefore, cos 90 is 0. Therefore, ultimately it's giving 0. That means, therefore, now the dot product can be expanded like this. You have to only multiply only with the Fx Sx, because I cap I cap and I cap, because these two being a scalar, okay, fx and sl being scalar, simply multiply it, and then I cap dot I cap, because now it is not dot, therefore now you just expand the brackets, you get I cap dot I cap, which is equal to 1, therefore plus, then I cap dot j cap, all the other terms will all go away because become 0, therefore now you have to deal only with j cap, therefore fy sy plus fz sz. Therefore, this is nothing but a sum of these three terms in the scalar. So then this is what is the dot product. Okay. So now we will do certain amount of exercises so that you will know how to tackle this dot product. Okay. Read this question number 9 and then try to solve it, and then see my solution. Okay, let's now do it. If vectors A cos omega t I cap plus sin omega t j cap, and vector B cos omega t by 2 I cap plus sin omega t by 2 j cap are functions of time, then the value of t at which they are orthogonal to each other. Orthogonal means perpendicular to each other. Okay, orthogonal means perpendicular. Okay, therefore orthogonal to each other means perpendicular to each other. That means mutually perpendicular. Okay, fine. Now the condition given is that A and B are mutually perpendicular. Now, if they are mutually perpendicular, mean then what is the condition? A dot B should be equal to 0. Why? Because A dot B is by definition A B cos of theta. Okay, if no angle between them has to be 90 degrees, cos 90 0 means they should now give you a value of 0. That is dot product should now vanish. Now then what is the value of t at which they will vanish is the question. Okay, fine. Now as you know, now we have already got it as in terms of components. Okay, rectangular coordinate components. What are they? Therefore, it is like this: cos omega t I cap plus sin omega t j cap dot product with cos omega t by 2 I cap plus sin omega t by 2 j cap. Now this should actually become 0. Now as you know, now I cap terms you just collect. Therefore cos omega t by 2 plus then I cap dot j cap is going to vanish, therefore don't worry. Therefore now collect the j cap dot j cap. Similarly sin omega t into sin omega t by 2. Therefore now this should be equal to 0. What is this? Sin omega t is actually, this actually stands for, this is cos A cos B plus sin A sin B, which is nothing but cos A minus B. Okay, or B minus A, both are same of course. Cos omega t minus omega t by 2. Okay, this should be equal to 0. Correct? No? This is A cos A minus B should be equal to 0. When it will be 0? When omega t minus omega t by 2, this becomes 90 degrees, that is pi by 2. Therefore, what is the meaning of the omega t by 2? Omega t by 2 should be equal to pi by 2. That means omega t equal to pi, or t equal to pi by omega. Understood? Understand how we did it? Therefore, that is the answer. When they will become orthogonal, means they will become orthogonal at a time t given by pi by omega. Okay, good. Therefore, this is how you must do. Okay, read the next question, question number 16. If a vector 2i cap plus 3j cap plus 8k cap is perpendicular to the vector 4j cap minus 4i cap plus alpha k cap, if the perpendicular means then dot product should become 0 because cos 90 is 0. Understand? No? Therefore, now it's like this now. How to do it? 2i cap minus 4. Just be careful. Don't go about reading I cap and j cap. This is the I cap term. Okay. Then deliberately they are given this like this, j cap first and I cap. Therefore, don't get confused by this. You must always now look for this. Read it correctly. Therefore, this actually means now 2 into minus 4 minus 8 plus 3 into 4, which is equal to 12. Then plus 8 alpha should now become 0. Therefore, then solve for alpha, right? Simple. Okay, you can do it. So that is what it is. Do the next sum, question 20. The angle between two vectors, A equal to 3i cap plus 4j cap plus 5k cap, and B equal to so much, will be how much? Now how to find the angle? It's like this now. If you take a dot product, Okay, let us take now A dot B is going to give you AB cos theta, and therefore the cos theta is given by A dot B by AB. What is AB? AB is modulus of A into modulus of B. This is going to give you cos theta. Okay, so and therefore once you know cos theta, you can find out the theta. Let's now do it. What is A dot B? Dot product between these two vectors, you just write 3 into 3, 9, plus 4 into 4, 16, plus 5 into minus 5, minus 25, equal to 0. Therefore, dot product becomes now 0. That means numerator is equal to 0. The denominator, how do you actually now take out modulus value of A is like this. Okay, remember this modulus value is to be taken as is equal to 3 squared plus 4 squared plus 5 squared square root. Okay, how is it like this? Because suppose now this is now A vector and this is a component A cos theta, this is now A sin theta, this is A cos theta, A sin theta. That means it's now Pythagoras theorem, this square plus this square will be equal to this square. Similarly, now here the Z component also is the X component square plus Y component square plus Z component square is going to give you the square. Therefore, take a square root again, you get the magnitude of A. Understand this? It is now pretty simple. Therefore, now this now 0 divided by A and B can be whatever it is. Now in this case, it is now 3 square plus 4 square plus 5 square for both. Okay, there's no need to calculate now in this case because numerator anyway is going to be 0. Therefore, now this means now cos the theta should be equal to 0. Then what is the theta? Theta equal to 90 degrees is the answer. Understanding? Good. Therefore, now we have practiced enough on this. You can do your own practice of various kind of questions on the dot product, right? We will now take up cross product. How to find cross product between two vectors. Cross product are also called as vector product, and it is written as A cross B vector. So then this is what, let us call it as now C vector is the result. Then how to find the cross product is like this. Now this let us say is A vector, this let us say is B vector, that even if it is somewhere else like this, we just now transpose that particular B vector, shift it so that is joined with A vector tail to tail, okay, like this. Now then what happens is, now the angle between them is theta. Angle between them, as you know, is from tail to tail mean, then it will be this theta which is marked. Therefore now the magnitude of C will be equal to AB sin theta. Okay, magnitude is this. Whereas now the cross product is, now you can recall the magnitude of the dot product was AB cos theta. Now this is nothing but this is now AB sin theta. Okay, then what is the direction of this? Because the vector product or the cross product is a vector, it will have a direction also. Direction is written as, suppose this like this, there is no magnitude and a normal unit vector. What is normal unit vector? Normal direction is perpendicular to the plane containing both A and B. I'll repeat, perpendicular to the plane containing both A vector and the B vector. Now in this case, what is the plane containing A vector and B vector? It is the plane of the paper. Therefore then perpendicular to the plane of the paper, which means it will either come out towards you, looking from the top, or be going, because coming out will mark like this, and then going in will mark like this. Okay, this symbol you know already, I suppose. Like this. Now what is this particular rule? This is now coming out or going in. Out of which then how do we choose means? Now you are now trying to multiply A vector with B vector. Okay, cross B vector. Therefore now first vector is A. Therefore from A vector, now you want to go to B vector through this particular angle theta. Theta is now like this, that is go from A to B. Now you are moving, looking from above the plane containing A vector and B vector. What is the sense in which the theta is obtained? That is, you are moving from A to B. Because first vector A, I repeat, second vector B means from A to B you have to go. Is it now clockwise or anti-clockwise? Looking from above, it is anti-clockwise. Anti-clockwise means then it is coming out of the plane of the paper. That is now so-called Z direction. Because you can now consider the paper as the XY plane, then it is Z direction. That is positive, because we know that the rectangular coordinate axes are like this. Then coming out is positive Z, and of course going inside the plane of paper is negative Z direction. We know is already. Therefore now we just apply this rule. Then you will get, now in this particular case you have got let me just now show you. In this case, you have got now this is A vector, and then this is B vector attached tail to tail, and then this is now the theta angle between them. Now from the first vector A to second vector B, you are moving in the anti-clockwise direction. The anti-clockwise direction means then it is coming out is the result C vector direction. This is called the normal unit vector. Whereas now the magnitude of this C is given by AB sine theta. Understood this? Now this is what it is. What I now explain is called as right hand rule. Now that is repeat now to practice just see this vector A cross B means vector. You just assume this is on the plane of paper, and then you are traversing from A towards B mean you'll have to make the angle theta like this. Right? Now supposing now there are actually no two angles if you can consider. Suppose now this is A vector, and suppose now this is B vector, okay, attached to tail to tail. Now the theta can be either this or this backside. Now you're always supposed to take the theta which is lesser of the two, that is which is now the lesser theta. This is now less theta, therefore you have to go from A to B like this means then you are traveling anti-clockwise. Okay, therefore now we must take the smaller theta and then do this exercise of looking at it from the top, whether it is anti-clockwise means then the product n unit vector is outside the plane of paper coming out towards you. Whereas if it is anti-clockwise, suppose now we want to know, therefore now you can see that B cross A will be same theta. That means now its magnitude will be same AB sine theta only. Whereas now the normal vector direction will be, because now the theta is now traversed is clockwise, it is got to be going inside direction minus k cap. Understand? Therefore now you can also see that A cross B is negative of B cross A. Okay, whereas now in the case of a dot product, you know, because it's only a scalar, doesn't matter whether it is B cross A, B dot A or A dot B, it will still have the same value. Whereas in the case of a cross product or the vector product, you have it as negative if you just reverse the order of the multiplication. Fine. Now this is what is the thing. Now you will have a different way of actually. Now let me now show this. What I meant to say was that if you just go through some other books, they'll give the same rule as what I said is now you have to look at it from the top and then decide from the first vector to second vector whether you are moving clockwise or anti-clockwise, depending upon that you can decide. Now the same rule they'll give it in a different fashion, which also is equally good, and then you can practice that also if you want it, whichever is convenient to. I would personally feel that my method, whether clockwise anti-clockwise, would be the most convenient for you. Okay, now later on I can also give you another kind of a method which will be very quick for you also, that you can consider. But in the meantime, as I said, now if you go through the books or coaching manuals, they'll teach you what is known as a right hand system like this. Okay, let me just now show you what I have in my mind. Now it's like this. Okay, what you need to do is just like what I said, you need to align the two vectors. Okay, now this is a vector. Sorry, we'll just now remove this. Yeah. Now let me now see. Now this is a vector, and then this is. I'm sorry, this is not working out fine. So let me now move it here. Okay. So now let me now see. This is a vector, but this is giving trouble. This is giving trouble. Why? Okay, I think I should rub it off. If I now rub it off, that should go away, hopefully. Let us see. Okay, so now this is A vector, and then this is B vector, aligned such that they are on tail to tail, and then what you need to do is you have to keep your palm, the open palm, facing the second vector B. Now in this case, that is, you have to keep this particular open palm along the first vector A vector like this. Okay, now your thumb will be pointing upwards like this. Now you have to keep it along this A vector, lined along this A vector, and then the open palm should be facing the second vector B vector like this. Okay, not ulta, not the reverse, not the back side of your no. This is where you should now keep it. Now you can see that then when it is like this, then your thumb is showing the product vector product direction, that is coming upwards, right? Now this is now same as what I said. Now travels from A to B in this direction. Now it is anti-clockwise, therefore it is coming out. Now the same thing is being shown in a different way. Now if you just now do this, for example, from this A vector, you are now showing like this. Supposing now you want to do B to A, then you have to keep the palm ulta like this, so that that open palm is now facing A vector. That is, you are aligning it with B vector and then facing A vector. Then what happens? Then your thumb will be actually going inside the paper, right? Now, I suppose now this particular thumb rule is a little difficult for you to imagine and then execute. So then stick to what I said about the clockwise anti-clockwise method. Supposing you want to do A cross B vector product, let's call it as now C. Now which we know is AB sine theta magnitude, and then the normal vector, unit vector direction, which we just now explained. Now in case now A and B are expressed as I cap, j cap, k cap, the unit vector method, like for example A x I cap plus A y component j cap plus A z component k cap. Similarly, B is expressed as B x component I cap plus B y component j cap plus B z component k cap. Now, first, therefore, then how do we now do this? A cross B is going to be now the cross product of this y component plus z component k cap cross product with the other B x component I cap plus B y component j cap plus B z component k cap. Now how to do the cross product of this? If it expressed as unit vector I cap, j cap, k cap method is like this. Now it is a kind of determinant way of doing it is I, j, k. Write it like the determinant. You know already how to do it. Then you write the first vector components, then the second vector component, and therefore now this is the result, that is C vector is given by this. Now how do you do it? How do you do this? I ay bz minus az by. Okay, this formula you know already about how to expand the determinant. This is I cap, this is now the coefficient for the I cap, plus similarly now j cap. Therefore you know how to do this particular exercise. Therefore do like this. Now otherwise, if you want to expand it fully like this by means of mathematical method, you expand it like this: ax I cap cross bx I cap, plus then you take ax I cap with cross by next term, plus then ax I cap into that is cross bz k cap. Okay, like that there will be actually how many terms? 9 terms will be there. Now you can expand like this and then apply what I am going to say. I cap cross I cap equal to 0. Why I say that? Because by means of definition we know I cap cross I cap is equal to I modulus into sine of angle between I cap and I cap. What is the sine of angle between I cap and I cap? 0 is the angle between the same vector I cap and I cap. Therefore now sine 0 is going to 0. Therefore I cap cross I cap is going to be 0. Similarly, j cap cross j cap is going to be 0. K cap cross k cap is going to be 0. Whereas I cap cross j cap is given by, now just apply that particular what I told you about the counterclockwise clockwise. Now this is the usual rectangular component coordinates. Now from I cap cross k cap means from x axis you are moving towards y axis. Now you are going in the anti-clockwise direction. Therefore now this got to be coming out from the pen and paper, which is nothing but k cap, because z, okay, was coming out. Now like this. Therefore then suppose we just do it ulta. J cap cross I cap will be, now from y axis you are going to x axis, clockwise means it will be going inside. What is going inside is minus k cap. Therefore now you have this particular, if you follow the rectangle cycle, okay, just write like this k cap. Then I cap cross j cap will be equal to k cap. That is a cyclic. From I j you get k. Then from j k you must get I, cyclic. Then from k cross I cap you must get positive j cap. Whereas now the ulta of this j cap cross I cap will have to be minus k cap. Similarly, k cap plus j cap should be minus I. Similarly, I cap minus j cap. Therefore, now this is now easy for you to do this. Now, therefore, now either you just expand like this fully and then do by means of this particular method I told you, or simply now easier you start out right in determinant fashion and then expand, right? Now this is what I want to say. Next topic what we are going to take up is like this. Next topic is, suppose a vector is given like this. A vector is 2i minus j. Then I want to take out that component of this a cap, okay, component of a vector along the direction of another vector b vector, which is given by 2i cap plus j cap. That is like this. Now this is a vector, and then and let's say now this is b vector. Okay, b vector. Now I want to know what is the component. Okay, that means you have to now consider the b vector as one of the component. Resolved component is along this direction. Okay, this is now the b vector direction. Resolve a vector into one of the component along the b vector direction, and then the perpendicular component is along. Therefore, I just want to know what is this vector. Okay, that means what we are now doing is we are taking the projection. Okay, what is this much length is equal to projection of a vector along the b vector. That means dot product. Understand? What is this? This is going to give you the projection of a vector along the direction of b vector, because this is b cap. Okay, unit vector along b. Then this is going to be the value of the length of this particular component. Then what is the direction of the component? B unit vector. Therefore, this is exactly what I want. When I say that I want the component, resolve A into component such that I want the component which is parallel to the B vector direction. Understand? Now this is what it is. Now it is now pretty simple to do this. What I want is A dot B. A dot B is now 2i cap minus j cap dot 2i cap plus j cap. What is it going to be? 4 minus 1 equal to 3 is the value. Then 3 is the value of A dot B, where I want A dot B unit vector. Therefore, divide this 3 by means of value of B vector. What is the value of B vector? Root 5. Therefore, this is what is going to be the projection of A vector along the direction of B vector magnitude. Then we'll multiply by the B vector unit vector. What is the B unit vector? I cap because what is B unit vector is equal to B vector divided by modulus of B vector. Therefore, then what is the modulus of is equal to root 5. That means now this is going to be what is the value of 6i plus 3j divided by 5. This is what is the answer what I wanted. This can be written as 1.2 I cap plus 0.6 j cap. Right? Now this is the answer. This is the component of A vector, given A vector along the direction of B vector. Fine. Now suppose now it's like this. Now I now change the question to something else. Like now I want, suppose now A vector is given as, let us say, 2i cap plus 3j cap. Then the B vector. Then the B vector is given as minus I cap plus j cap. Now the question is, now I want component of A vector along a direction perpendicular to B vector. Right? Now last time the question was along a direction which is along the B vector. Now I want the component along the perpendicular to the B vector direction. That means what I am not trying to say. Suppose now this is my A vector, and then this is my B vector. Therefore, now what I want is, I just now reproduce this particular direction of B like this line, and then drop a perpendicular from A like this. What is this A vector can be considered as? Now this is what is the question what I asked last time. That is along the direction of B vector, whereas B vector is like this, along direction. Now I am asking this, what is the component of A is this plus this. Okay, this plus this. Therefore, now I'm now looking for answer of this vector. Okay, vector direction is upward. That is perpendicular component. Now, how to take it out is like this. Now, we can find out just like what we did last time. We can find out this particular vector. Now, then what we can do? We can subtract this vector from A vector, because let us call this as now C vector. This as now is called a D vector. Therefore, now A vector is equal to C vector plus D vector. What I want is now D vector is equal to A vector minus C vector. Then how to find the C vector? C vector we can find it as is now projection of A vector along the C unit vector, and therefore this is going to projection value multiplied by the C unit vector is going to be the component along the C vector. This is what is the C vector. Therefore, now what I want basically is I want the D vector, because A vector is given minus now the C vector is given by A vector dot C unit vector times C unit vector. Right? This is what is the answer, what I want. Okay, let's now do it. Now what is this? A vector is given by 2 I cap plus 3 j cap. Therefore 2 I cap plus 3 j cap minus of now A dot C unit vector. Therefore what we have to do is A dot C unit vector is this nothing but A dot C dot product divided by modulus of C. Okay, this is what it is, right? And therefore now this can be written A dot C is now 2, therefore minus 2 plus 3 equal to plus 1, right? Therefore 1 is 1 divided by what is the modulus of C equal to minus I cap plus j cap. What is the modulus root 2? This is what is the C vector multiplied by C unit vector again is nothing but minus I cap plus j cap divided by modulus of C is root 2. Therefore what I am saying is 2 I cap plus 3 j cap minus 1 by 2 minus of 1 by 2 multiplied by minus I cap plus j cap. Therefore plus I cap by 2 minus j cap by 2. Therefore the answer is 5 by 2 I cap plus 5 by 2 j cap is the final answer. This is the component along a direction perpendicular to the B vector. Okay, understood? Now this now completes this exercise. There is a concept involved in the vector products, right? Okay, therefore now we are now ready to do problems and then understand how to apply the knowledge what we have gained. We will now start doing problems. Read this question number 7. The moment of a force F is equal to 4 I cap plus 5 j cap minus 6 k cap at 2, 0, minus 3 coordinate about the point 2, minus 2, minus 2 is given by 2018 NEET asked question. Now, what is meant by moment of a force you know already is this called the torque also. So let me now do that. If you have forgotten, then the torque formula is R cross F. What is R? R is a position vector of the point at which the force is applied relative to the origin which is about the point. Now in this case, now R vector is what is the point at which now the force is applied? This point. Therefore, then what is this point as a position vector of this point with reference to origin as considered as this is origin. Okay, so now this is what it is. What is therefore then R vector is given by 2 minus 2, 0 I cap, 0 minus or minus 2 plus 2 j cap, minus 3 minus 2, minus or minus 2 equal to minus k cap. Therefore R vector is like this, 2 j cap minus k cap. Then what is the F vector is already given as 4 I cap. Therefore now the torque vector what you want is nothing but R cross F, 2 j cap minus k cap cross the F vector which is 4 I cap plus 5 j cap minus 6 k cap. So then as I told you, then you can follow the determinant method I, j, k followed by first is R cross F. This is R, this is F. Therefore now you write 0, 2 minus 1 and then F vector is 4, 5 minus 6. Determinant value how do you write? I cap into 2 minus 6 minus 12 minus of minus 5 plus 5 is 7. Then plus j cap minus 1 into 4 minus 4 0 minus 4 plus k cap. k cap, this is 0, and then this is minus 8. And therefore, what is the final answer? 7 I cap minus 4 j cap minus 8 k cap is the final answer. Check where is it? Minus 7 minus 4 minus 8. 7 minus 4 minus 8. Somewhere something is wrong, therefore, okay, fine. Now you can do it correctly and then get to know this. So, minus 7 is wrong. Actually, it should be plus 7. Okay, there is mistake in the options. You can do it, right? So now this is the way it is to be done. Now let's take up the next problem. Consider the next question, question 12. Vectors a, b, c are such that a dot b equal to 0 and a dot c equal to 0. A dot b equal to 0 means angle between them is 90 degrees. That means a and b are perpendicular. That is, b is perpendicular to a. And similarly, now from the second condition, a dot c equal to 0, you can make out that c is perpendicular to a. That means both b and c are perpendicular to a. Therefore, then the vector parallel to a is, I just repeat that you have just concluded that both b and c are perpendicular to a, which means now b cross c has to be perpendicular to both b and c. Now look at the option D. Option D is b cross c. B cross c therefore has to be perpendicular to both b and c is by the definition of cross product, which means it should be a or parallel to a. Therefore, what they want is vector parallel to a. Therefore, now D is the answer. Because if it is a cross b will be perpendicular to both a and b. That will not meet the condition of vector parallel to a. Therefore, this is not possible. And then b and c. What is vector parallel to a? No. Obviously, now it is a, both b and c are perpendicular to a is the conclusion from here. Therefore, this cannot be there. Therefore, obviously, then addition of the b plus c also should be lying in the plane containing both b and c, which means it will be in a plane perpendicular to a. Therefore, it will not be parallel to it. This also is not correct. Therefore, we have got only this answer is the correct one. Understood? Good. Read the next question. Question number 18, asked in 2004. If modulus of a cross b equal to root 3 times a dot b, then the value of modulus of a plus b is, oh my, there are 4 options given. Now let us now try and then do this. Okay, modulus of a cross b will be equal to, that is, no, this is equivalent to, I'm sorry, one second. This is equivalent to, that is, left hand side is equivalent to AB sine theta. Angle between A and B is theta. This will be equal to root 3 times A dot B means root 3 AB cos theta. This means tan theta equal to root 3. That means theta equal to 60 degrees. Now we go to what they want. They want the modulus value of A plus A plus B. A plus B is given by square root of a square plus b square plus 2ab cos theta is half. Therefore, plus ab. Okay, now see then which option is there. Option B checks. Okay, good. So now you can continue. There are now for practice I have given enough number of questions from the past asked questions, both from NEET as well as from JEE Main. You can practice that. Plus also you can practice all other questions, whatever you can lay your hands on from any books or teaching manuals or coaching manuals. Okay, so then this should complete all the concepts involved in vectors. Then the subsequent in this particular chapter what we are now handling, which is motion along a plane, then we still have to cover concepts on projectile motion as well as relative velocity concepts on 2 dimension as well as circular motion. Therefore, this will be now taken in the next session. Thank you.